Good morning, everybody. This is Unit 3, Constructions, Day 9. I'm your host, Mr. Kaya. All right, so this is Part 3 with constructions with triangles, okay? And so we're going to talk about the altitude of a triangle. All right, so when we were doing area and volume, okay, when we were using that formula 1/2 base times height, okay, your height is what we call the altitude, right? Okay, how tall is your triangle? Okay, and so in geometry, an altitude of a triangle is a line segment through a vertex and perpendicular to a line containing the base. This line containing the opposite side is called the extended base of the altitude, and then the rest of the definition just says the intersection of the extended base and the altitude is called the foot of the altitude. Okay, so really what I want you to take from that is, as you can see in the picture here, okay, sometimes your altitude can be found on the inside of the triangle, like you see over in this picture here, okay, to the right. Sometimes your altitude can be found on the outside of the triangle, which that's what the definition was talking about up there. As you can see, they've extended that base all the way out so that you get a perpendicular line with BD, okay, and again, this is on the outside of the triangle, right? So sometimes your altitude can be found on the outside. And then right here is a right triangle, all right? And so in a right triangle, all right, either one of these sides can be used as an altitude, right? Because it is perpendicular with that opposite side here, okay? So anyway, basically the altitude of a triangle is a line segment from the vertex that is perpendicular to the opposite side, right? And that is also what we call our height. Okay, so when we're using area and volume, okay, our height is also referred to as the altitude. Okay, now essentially, all right, you can use any vertex, okay, and send it to the opposite side, creating a perpendicular line as your altitude. All right, so as you can see, we have the same triangle, 3 different altitudes, right? And so in retrospect, you can use any vertex and any opposite side to measure the height of that triangle. However, sometimes it's easier to use one side than another, right? If I was using this right triangle up here, I wouldn't necessarily use this side here, right? I wouldn't use that as my altitude because, well, I'd have to find that distance, right? So why make things harder on yourself, okay? So just keep that in mind when you're asked to find the altitude of a triangle, okay? You want to pick the easiest one. All right, and in the last part of this lesson, we're going to be talking about the orthocenter, which is basically the intersection of all 3 altitudes, right? So, and as you can see in the picture on the left and on the right, all right, but on the left, you can see all the altitudes are on the inside, right? We got 3 90-degree angles here, letting us know that from that vertices to that opposite side, it's perpendicular. As you can see, all 3 altitudes intersect at that same point. Okay, that's called the orthocenter. All right, and sometimes, as you can see in the picture on the right, okay, that orthocenter appears on the outside of the triangle. So it all depends on the shape. Okay, but what's kind of neat is that all 3 altitudes will meet at the orthocenter. Okay, pretty cool. So, number 1, I just say find the altitude of the following triangles. Okay, so in this one, like I said, this is a, well, forgot to put that in there for you guys. All right, this is a right triangle, right? Okay, so technically we could use either altitude here, or I'm sorry, either side here for our altitude. So this side over here, if we use this side, our altitude would be 1, 2, 3, 4, 5, 6, 7. So it could be 7 units. Okay, or you could use this side right here as an altitude as well. 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, 18 units. Okay, and so I would suggest if we were asked to find the altitude of this triangle, I would use either one of those, right? Because those are the easiest ones to find here. We could use this one again. go. Anyway, oops. So we could use that as an altitude if we wanted to, right? But we would have to find that distance. I mean, that's not totally accurate, but you get my point here. Okay, so let's take a look at number 2. All right. Now again, we could use any of these vertices, but I would suggest using the easiest one, right? We're going to use that extended base. Okay, so I extend my perpendicular line out here, drop it down, and now we can use this side right here as our altitude. So this is 1, 2, 3, 4, 5, 6. Again, that's just 7 units. Okay. All right, or, you know, I guess since we got it right here, we could use that side as well. So it could be 7 units, or 1, 2, 3, 4, 5, 6, 8, 9, 10, 11, 12, 18 units as well. Okay. So, and finally, the last one, all right. Not quite sure if that's a right triangle, okay. Pretty sure it's not. So our easiest altitude would be this one right down the middle here, right? I'm going to go from B all the way down to AC, creating a perpendicular line. And then my altitude here is 1, 2, 3, 4, 5, 6. Oh, how about that? 7 units. Okay, so as you can see, different shapes for the triangle, but all of them have the same, you can utilize the same altitude, which was 7 units. Okay? So let's take a look at number 4. It says find the altitude of the following triangle using vertex B and the line segment AC. Okay? So we're asked to find the altitude here, and it's telling us to use this vertex and create a perpendicular line with AC. All right, so what we're looking for is a line going from here all the way down here, creating a perpendicular line. Okay, so I'm guessing it might be somewhere around that area. Right now I can't assume anything. All right, so I'm going to show that. All right, so what is this point right here? Well, this point is -2, 4. Okay, and in order to create a perpendicular line through that point with AC, okay, I must find the slope of AC. Okay, so this point right here is -9, 0. This point down here is 3, -8, right? And I'm going to use the point slope formula. Okay, so this is going to be x1, y1, x2, y2. So m, or our slope, is equal to, I'll write the formula here first. So we get y2, which is -8, minus y1, which is 0, all over x2, which is 3, minus x1, which is -9. And so we end up getting -8, and 3 plus 9 will give me a 12. And so I'm going to divide each of that by 4, and I get a -2/3. And so let's check that. All right, let's see. Down 2 over 3. Down 2 over 3. Perfect. Okay, so you can always check to make sure what you get for a slope, okay, works out here. All right, so it's a quick little way to just check your math there and make sure we got the correct slope. So now, all right, because AC, its slope is -2/3, all right, then the slope we need is going to have to be the negative reciprocal, right? Okay, so if the slope of AC is -2/3, then that perpendicular line to AC, that slope has to be a positive, whoops, that's not it, 3/2. Okay, so here's our new slope. And then here's our point, which is going to be -2, 4. Point slope formula, except this time I'm utilizing it to create the equation. And so I'm going to go y minus y1 is equal to our slope, x minus x1. Whoops. Fill in the blanks here. So you end up getting y minus 4 is equal to 3/2 x plus 2. And then I'm going to have to simplify that even further. Give myself a little more space. Y minus 4 is equal to 3/2 x, and that's going to be 3 times 2 is 6, divided by 2 is 3. Add 4 to both sides. So our new equation is this guy right here. So this is the equation of the line that is perpendicular to AC and through point B. Okay? So let's see if that works out. Now we aren't going to be able to use our y-intercept. In this case, our y-intercept is 7, right? And as you can see, we don't have that on our graph here. So I'm going to start at B, though. And because I can't go up 3 over 2, I'm going to go down 3 and back 2. Down 3, back 2. Down 3, back 2. And as you can see, if I was following the correct slope, I could go up 3 over 2, up 3 over 2. And I fall on that same point. So I'm just trying to get down 3, back 2. And there's the equation of that line that goes through that vertices. And as you can see, let me erase some of these marks here. Right, goes right through this point. -6, comma, -2. Okay, so finally, what I can utilize now is the distance formula. And so this will finally give me my altitude, right? Because this distance formula will let me know the distance between B, and we'll just call this point right here point D. All right? So line segment BD, okay, is equal to, those points again, so -2, 4, and -6, -2. So I'm going to go x1, y1, x2, y2. Distance formula is x2 minus x1 squared plus y2 minus y1 squared. And so you just fill in the blanks. x2, -6, minus x1, which is just going to give me a +2, plus y2, which is -2 minus y1, 4. Okay, so -6 plus 2 will give me a -4 squared, and -2 minus 4 will give me a -6 squared. And so finally, underneath the radical, I get 16 plus 36, which is 52. And so the square root of 52, because I didn't specify how to leave it, so I'll just give it a nice decimal number here. So the square root of 52, 7.21. And so that is the altitude of line segment, or the distance, or I'm sorry, the length of line segment BD. And so our altitude is 7.21 units. Okay. All right. So, number 5, I will try to show in class. Okay, so we will do this one in class, and then also we will do this one in class as well. Okay, so we will practice both of those, but for homework, I want you to give me the 3 altitudes here that you would utilize. Okay, and then I want you to try to practice these constructions right here. Okay, so your homework is those altitudes and those 3 constructions. Constructing the altitude of a triangle, and then finding the orthocenter, which again, the orthocenter is the intersection of all 3 altitudes. Okay, and we'll practice that in class on Thursday and Friday. All right, you guys have a